So let's see if we can answer this silly question. Does the s squared plus c squared that equals one thing work? So again, what I mean is sine squared of an angle theta plus cosine squared of an angle theta is 1, right? Okay. Do I have sines and cosines for some angle off the top of my head that I can possibly check this with?
Yeah.
Good. Okay. So let me check with 45. So maybe example-ish. Sine squared of 45 plus cosine squared of 45 maybe is something. Hopefully 1, right? Okay. So let me fill in what I know it is, and we'll see if it's 1. So what's sine of 45? Okay. You guys want to use this one today? Fine. Square root of 2 over 2? No? Sorry, I had strong feelings the other way. So 1 over square root of 2. What do I need to do with this thing? Square it. Be a little careful with these guys, right? This means do sine first, then square it. So when you're thinking about this, this is really sine of 45 all squared. You guys see that? We're going to do confusing exponents like that a few times in here. Just remember that exponent goes afterwards, unless it's a -1, in which case it means something else. Cool? Sorry about that. I wish I could change it, but that's actually just the way things are at this point. Okay, so that's sine squared. What's the cosine of 45 degrees? 1 over the square root of 2. And I should be squaring that. What do I get when I square these? 1 over 2 plus 1 over 2. So if you have half a pizza and your buddy throws half a pizza at you, how much pizza do you have? I think you have a whole pizza. Yes? Cool, check. It worked for 45 degrees. Right? Let's try something else. Okay, let's try, what do you want to try, 30 or 60?
60. Either one, I don't care.
Okay, I'm going to try 30 because it was suggested first. So sine squared of 30 plus cosine squared of 30. Okay, what's sine of 30 degrees? Thirty sine 1/2. Do you guys see that? That's actually exactly how I do this. Okay, I'm not kidding you. There's no deeper technique here. I don't have this any more memorized than you do. I go over to the side, I build the triangle, even if it occasionally happens in my head, I build the triangle, and then I read off the adjacent and the hypotenuse, or opposite and the hypotenuse in this case. How about the cosine? Okay, that should be root 3 over 2 squared. Gives you, what's a half squared?
1.25.
Worker. And square root of 3 over 2 squared is, I think, 3 over 4. You have a quarter of something, and 3/4 of it falls on you from the sky. How much of it do you have? You have a whole one? And a pain in your head from, yeah. Cool. Check. Okay, how did I know this was going to work before I started doing this?
Because it needs to be.
Worse yet, how did I figure out this side of this 30 to 60, 90 triangle? Do you guys remember? I used the Pythagorean theorem to figure it out. So then I forced this to work for 30 degrees, right? Because I used the Pythagorean theorem to figure that side out. How do I know the Pythagorean theorem works? Because I have a right triangle. And how else did we do the Pythagorean theorem? Like, why do we know that thing is true?
I remember that.
There's like this kind of nasty diagram chase and a little bit of algebra. Yeah. So Remember, none of this is magic, right? I built it out of squares at the beginning of the day. And it has to work that way because geometry, I guess, because of the definitions of numbers. You guys see this? So, although this seems complicated, right, it falls all the way back to the beginning and becomes squares at some level. You guys cool? You buy into the Pythagorean identity now? Any of you believe it's useful right now? Probably not, which is totally fine. I promise it's useful later. Cool? All right. Let's call it.